right, so we're going to go over classifying quadrilateral in a coordinate plane. First step, always draw a picture of the quadrilateral and plot the points. Here, they've already given it to us. So we go to step 2. We got to use the distance formula to find out what the lengths of the sides are. So let's try to figure out what's the distance of side AB. You want to use the distance formula. If you have to go look up that in your notes, difference of the x values squared plus the difference of the y values squared. I'm going to work that out. -3 subtract 2 is -5. And 3 subtract 5 is -2. -5 squared is 25. -2 squared is 4. We get a distance of square root of 29. Now, I usually move to the opposite side then. What's the distance of C to D? Again, use the distance formula. 4 subtract -1 squared plus 0 subtract -2 squared. We should end up with a square root of 29. So we have square root 29 on the opposite side. Now we got to figure out the other two sides, AD. AD, again, use the distance formula. So -3 subtract -1 squared plus 3 subtract -2 squared. Work this out. Again, I'm going to use a calculator, although you should work it out. Will be the square root of 29. So again, mark it on your picture. And we've got our last side, which is BC. And that's going to be the square root of 2 subtract 4 squared plus 5 subtract 0 squared. Simplifying that, we get the square root of 29. All right, so we go to our chart of characteristics here, and we notice that all of our sides are equal. So all of the sides of the quadrilateral are equal to each other. Well, that has a lot of possibilities here. We've got rhombus. We've got square. The next thing that we have to figure out, well, and that actually takes out, let's see here. That's pretty much what we got so far. So we need to figure out, are the opposite slopes just equal to each other, or are the adjacent slopes opposite reciprocals? Okay. So that takes us back to our problem here, and now we have to figure out what's the slopes, what are the adjacent slopes. So I'm going to clean this up. And now we want to figure out what is the slope of each of the sides. So slope of AB equals 3 subtract 5 over -3 subtract 2. Simplifying that, -2 over -5 becomes 2/5. So slope of then the opposite side, which is CD, that's going to be, oops, um, 0 subtract -2 over 4 subtract -1. That turns out to be 2/5. I better write these down on my picture so I don't forget about them. And now we've got the slope of BC, which is going to be 5 minus 0 over 2 subtract 4. That gets us negative 5 halves. And the slope of AD, setting that one up, is going to be 3 subtract negative 2 over negative 3 subtract negative 1. Gets us negative 5 halves. So I'm going to write those into our coordinate plane here. What we then need to take a look is we've got opposite slopes equal. So we for sure have a rhombus. But we need to see if this rhombus is also a square. So to do that, we're going to take a look at the slopes, adjacent ones, this slope and this one. And if we multiply them together and get negative 1, we'll know then that they're perpendicular, which makes a right angle. So let me clean up my whiteboard here. Take a look at our first pair. Negative 5 halves times 2 fifths. That gets us negative 10 over 10, which is negative 1. Take a look at our next pair. We've got 2 fifths times negative 5 halves. That gets us negative 10 over 10, which is negative 1. Take a look at our next pair, which is 2 fifths times negative 5 halves, which is, again, negative 1. And our last pair, negative 5 halves times 2 fifths, again, gets us negative 1. So we've proved then that all of these slopes and these sides are perpendicular to each other. So they create 90-degree angles. Well, if that's the case, then our best answer is square. So ABCD is a square.